You said I should be wearing a jacket. I am. My new hoodie from Holly.
That's not a jacket.
And then I'm making a mad face because the sun's in my eyes. But we're working on a Jeep and it has a lean condition. And we're gonna see what type of lean condition we have.
That was like the least attention grabbing. Do that again. Have more energy. You gotta think audience retention.
I know, I don't,
You guys?
no, I'm not doing that. It's cold and the sun's in my eyes and I'm making a mean face. We want to see as little of my face as possible.
Well, amen to that, but.
Okay. So yeah, we're at Latour's Auto. We're working on a Jeep. It has a 174 code in memory. It failed emissions and it has a lean condition. That's what a 174 is. So let's see what kind of lean condition we have. We're gonna do a full code scan. System lean 174. That's the one we're chasing. And honestly, we're just worried about the engine. Given the symptoms, which I don't think there are any, I think the customer complaint was maybe a little bit of a roughness at idle. We're suspecting a vacuum leak. I have no codes in any of the other systems other than the BCM, some irrelevant stuff for us, and airbag code too on the left side. Okay, so system lean, generic functions. Let's see what our freeze frame data shows. Just using this as a gauge. What type of lean condition do you have? We're looking at freeze frame data. Primarily, we're looking at engine RPM, engine load on when this code's set. So this is bank 2. There's your code up top right. I want to look at bank 1 as well. Long-term trim on bank 1 is showing -3. Long-term on bank 2 is positive 3.9. Those don't look bad. Short-term on bank 2 is 32%, while bank 1 was at 0. So that's looking more to me like a potential oxygen sensor problem maybe. There could be other things too for sure, but seeing that with bank 1 being 0 and bank 2 being 32%, I don't know that that suggests vacuum leak to me. This was at 1600 RPM. Yeah, absolute load was 62%. This was not at idle. Calculated load was 85%. This is not gonna be a vacuum leak. Vacuum leak, you're looking at numbers that are skewed at lower RPM ranges and lower engine loads, and it would typically affect both banks. Unfortunately, it doesn't give me oxygen sensor parameters in this freeze frame data capture, but that was actually pretty helpful as far as direction goes. So we want to see some data now, oxygen sensors in particular. All right, we'll just look at these top 6 data parameters. I have the O2s pulled up top, and then short-term and long-term fuel trim on both banks. These run a 2.5 volt bias. 2.5 volts on these is 0, the equivalent of 0. 2.5 is our 0 line, so 2.5 to 3.5 is the range this will run because they're using a ground bias on the sensor. If you guys have questions on that, I have lectures on this. This will be in my chapter 4 or chapter 5 playlist on my website where I talk about this characteristic where they're using a ground bias. It's essentially a 0 to 1 volt sensor, but it's using 2.5 volts on the ground, so it shifts everything up. So 2.5 is 0, 3.5 is 1, okay? Just so as we're looking at these O2s. All right, starting it. I'm interested in how fast these warm up. Ignore those spikes. That's just a real narrow scale right now. All right, you see how those sensors dropped real quick? Both the heaters are working, so that's a good first check on these O2s. The minus short term on bank 2 is countering the long term, so whatever problem was there before is not there right now. That's what that means when you see these counter fuel trim numbers. This is, I'm pretty sure, going to be an oxygen sensor problem. In particular because of what we're seeing here with the long term and short term, that right now they're countering each other. But we're gonna watch this O2 and see if it does in fact die on us. Right now it looks good, right now it's functional. Sorry, I did pick the 0 to 1 O2 readings. That's why it dropped from 2.5 down. If you looked at, say, this one down here, you can see where the actual O2 voltage is on the 1.1 sensor. And then, yeah, you see the 2.1 right here. You see that range I was talking about, that 0 or 2.5 to 3.5. But we're using calculated numbers now That's what the data is, that's fine. Yeah, so looking at the counter trims, long-term is the memory of long-term saying add 14% more fuel. We're now in closed loop. Oxygen sensors are in play. In particular, we're focused on bank 2. That's where our problem is. But you see the short term is minus 10. And so basically that's countering what the long term is saying, which is add fuel. Short term saying take it away. So that's what I meant when I said this problem is not occurring right now. Whatever caused this problem is not here right now. When I see intermittent fuel trim problems, I'm automatically suspecting I may have an oxygen sensor problem. So I'm just holding my RPM up higher now just to kind of get things heated up quicker. That's weird at this higher RPM. My short term over here on bank 1 is showing positive. I'm pretty sure what we're gonna end up seeing here is this oxygen sensor fail. You know, why'd it go rich up here, guys? Because memory said add 14%. It took a bit for the short term to come in to take it away. The short term on bank 1 is showing 13, 14% now. How strange. I'm at a higher RPM again. I don't think I have RPM on here. You guys can watch. Yes, I do, right there. Engine RPM's right here now. You see the trims are still countering each other here on bank 2. So this problem is not here right now. We gotta go drive it. Okay, let's watch these O2s and fuel trims while we go drive this. You guys remember the O2 tests I told you you can do on any car? Decel fuel cut and XL fuel enrichment. I'm decelerating right now. You guys can see how lean the O2s are. That's completely normal. There's your lean side. And then you just do a brief wide open. There's your rich side. And I had a comment from one of you guys recently. He said, hey, you know, those are good tests, but that doesn't show you O2 accuracy. And you would be correct. That test that I just did, showing you the full lean and full rich sides on the O2, is just simply a replacement for the propane enrichment and vacuum leak testing that's been done for years and years and years. I don't need to add propane to see if the O2 goes full rich. I don't need to make a vacuum leak to see if the O2 goes full lean. I can just simply drive the car and watch both ranges of that. And when you would use that test is when you have fixed O2 signals, or when you don't know the range of the sensor that you're checking. So a lot of these cars use widebands that, you know, a wideband sensor reports in like the 4 milliamp range, right? 4 milliamps is a super tiny number. And they don't report that on the scan tool on a lot of cars. They'll use a voltage equivalent, and all the cars are different. So if you're looking at an unfamiliar sensor and you're not sure, well, which number here is rich and which number is lean, you do that test. Test drive it wide open for your rich side and decel for your lean side. Look at your numbers. So that's when you'd use this test. For us right now, it's not important because, at least currently, because our problem does not exist right now. Look how nice these trim numbers look. So some other things that can give you a lean condition on one bank, a misfire can do that. Whether it be ignition or injector. Injector is going to be more lean than the ignition one is, but both will be lean. But you would think that this would set a misfire code if that was happening. Let's say if we had an injector that was intermittently shutting down. I know these injectors have monitored circuits electronically, so it would have an injector circuit fault. It's probably not going to be that, probably not going to be ignition related either. We would have misfire codes, you know, of course a vacuum leak, but for a vacuum leak to affect just one side of the engine, it would almost have to be the intake runner, and those don't typically fix themselves. We have an intermittent problem. What I didn't look at on the freeze frame data was what engine temperature we were at, but we were under load when the condition happened too, so that moves me away from a vacuum leak too. And to restate, vacuum leaks on intake gaskets don't fix themselves. Well, there is a variable to that. Temperature, they can seal up, like leak only when they're cold. I have some case studies on that right here on YouTube. We'll link a couple of those where we had intake gaskets that were more pronounced when the engine was cold, almost went away completely with the engine hot. So you can have that. That's why I mentioned engine temperature. I didn't look at temperature, and I should have on the freeze frame. Look at my long term right now, still at idle in park is still 14. And that's why that O2 just pegged rich on us. Short term's going negative, saying, ho, ho, pull it away, pull it away. And that's what you see, that counter fuel trim. So that will relearn itself. You see that happening right now. It is actually relearning as we're watching it. You look at the long term and short term. I have some lectures on fuel trim. You guys need to watch them, understanding short term and long term fuel trim. But I paused here on our drive because I want to see what temperature the engine was on our freeze frame data. So exiting out of here, generic functions, freeze frame. Okay, so this fault code, 25% throttle. Again, our calculated O was 85%. Trims on long terms look okay. Short term was the one bank 2, right, 32%. Engine coolant 194. So the engine was warm. We were going 36 miles an hour at a calculated load of 85%. I wish they would give me the oxygen sensor data on here, but they do not. Plus it's only a single capture anyway, so even if they did, it might not be all that valuable. Time since start, 716 seconds. What is that? Yeah, it's like 12 minutes. We've already had that, huh? We just gotta make it happen. These O2 signals look bigger now because I exited out of the data and it readjusted the min-max scales. That's all that is right there. I need to see this thing act up on me. What we're gonna see first is that O2 sensor for sure on bank 2 sensor 1. That's on the right-hand side. It's gonna go lean. It's gonna go lean, and then we're gonna see the short term start to go positive after that. If I can't make this happen, the only other thing we're gonna do today is we're gonna take a look at that 2.1 oxygen sensor and look at the harness routing and see if we have any rub marks at all where it may be touching ground. Damn. Completely unsuccessful. Visual inspection, and then we're calling it, man. There's no reason to get involved. There's no reason to measure fuel pressure, things like that, not when it's one bank. Scope and fuel injectors, ignition system, none of that's gonna be relevant, not without fault codes or direction that would put me that way. I would think too, if the oxygen sensor wires were touching ground, we would have some type of circuit fault with the O2s. We don't have that either. I don't know what's going on with this. Very, very strange. Yeah, so what would you guys do at this point in this diagnosis? What would you do? Would you throw an O2 sensor at it? Would you bill the customer for, your initial hour of diagnostic time? By the time we're done with this, it'll probably be an hour, even though you're not coming up with any conclusion. You can justify that by doing tests and writing down the tests, and maybe don't call it diagnostics. Write down what tests you did for the customer so they understand, and you bill them for it. Do you not bill them at all? Do you just kick it down the road and say no charge, sorry, come back whenever it happens again? All of these things that I've done, all of them, even shotgunning a part at it, I have done that. If this is my own car and I'm taking a trip, I'm bringing an oxygen sensor with me, or I'm changing it before I go. But one of the things I'm not doing in that scenario is I'm not going on Amazon and buying parts. I would absolutely source a factory O2 sensor for this. Let's go do a visual on this O2 sensor and cross our fingers that we see something. Caleb, all you missed was Pete was talking about the map sensor was changed by whoever scanned it, AutoZone, and then we have a coolant. What's this?
Oil.
It's an oil cooler. When was that done?
About a month or so ago.
And when did this problem start?
He actually had a problem before, and at the same time I changed the plugs. He had changed the plugs in the coil.
So he had some misfiring.
He just wanted them changed because I was in it.
Okay.
So no misfire.
Which one's bank 2? Is this bank 2? Or is that bank 2?
This is bank 2.
This is bank 2? All right, I want to look at that oxygen sensor. I'm just trying to do some visual inspections on this O2. there's nothing I'm going to be able to show you guys I'm looking at, not real easily. I don't see anything, nothing obvious as far as visual. I smell coolant. Look at this, in the battery hold down, that's antifreeze. But this radiator hose is new, so it probably blew. This tube is new. Somebody's been in here. Yeah, I mean, it has a coolant burning smell to it. Watch my O2 as I'm kind of just wiggling on some harnesses. Just kind of moving the O2 harness. So it's interesting too that this coolant hose that was replaced would be right above that oxygen sensor. I mean, it could have been contaminants from the outside. Let's go ask Pete a couple more. Oh, he wasn't real clear to begin with. You know, they changed the map sensor. I don't know why you'd change a map sensor for a single side lean condition. If a map failed, it'd be both sides, not one side. We're walking away from this, Pete. It's perfectly fine right now. If you look here, I'll show you the freeze frame data one last time, but look how nice these numbers look right now. There's bank 1, looks perfect. Right. Bank 2 is the one setting the fault codes. It looks perfect too, right? O2's moving up and down like they should be, but look at this freeze frame data. Just kind of show you what we're dealing with when this acted up. And it was, you know, the engine was hot, it was being driven. They drove it for about 12 minutes on this data capture. Right. And what we see is a short-term fuel term right here, 32% positive, while at the same time, look at the bank 1, long-term is 3, bank 1 short-term is 0, bank 2 long-term is 3, or minus 3 and positive 3, but those are good. But look at bank 2 short-term is 32%. So something happened here where that oxygen sensor was full lean and the computer was adding a whole bunch of fuel. Now the question is was that an actual lean condition or was that a faulty O2? Really, that's what we're talking about here. I'm not confident. Yes, I'm not confident enough to say put an oxygen sensor in this. If it was my car and I was driving to the beach, I'd probably put an oxygen sensor in this. But I'm not confident enough in that to say that for a paying customer. I really think that they need to drive it.
Drive it more.
Well, the other thing, I have some unknowns, is when was this coolant hose changed? This looks brand new.
Yeah, this one just changed.
When?
Just like a week or so ago.
When did this problem start? After
Probably
that?
I think
after this hose rupture.
So what happened with that hose? Listen, the hose, the factory hose has a plastic nipple on the radiator hose itself.
Yes.
So they discontinued, they don't sell that no more, so you have to buy a new hose with this tube.
Yep.
Change the tube.
Yep.
So what he had, this is what he had to get her home. He put a hose over top of there and over top the radiator and clamped it. Antifreeze was leaking everywhere when it was brought to me. So antifreeze was all over.
Okay.
So yes, that antifreeze was way before then this antifreeze happened.
So this started first though, before this current situation.
Yes.
That makes me feel like so much better to roll the dice and put a sensor in this, because it sits right there.
Right.
You probably got antifreeze down inside of that oxygen sensor.
Right.
In that sensor itself.
Right.
And you have an air. You can see that. Caleb, come over here so you get a shot of this. There's an air port. You see the little white part in the middle of that sensor?
Right.
That's your air inlet for that oxygen sensor.
So
it might be okay. Like they might have driven it enough now that just clear it and drive it. Like they might not have to do anything, but based on
if it happens, the O2 sensor will need change. Probably.
If it happens again, make sure he's open to that possibility.
Right.
And you know, if it's mine right now, I would drive it and clear the codes and watch it. I mean, obviously a customer doesn't have that option.
Right. But obviously with that antifreeze going all over there, that very well what could have happened.
Yes.
Okay.
Yes.
Yeah, it was bad. It was antifreeze was everywhere.
Yes.
So yes, you said you smell antifreeze. That was like you said, the month or so ago. Then
but this was recent.
This happened like a week or so ago, yes. and then after he had me put that map in.
Yeah, I hate rolling the dice, but this is either going to be A, it's already fixed and it's already burned itself off.
Right, burned off.
Or B, that's going to happen again and it's probably going to be that upstream O2.
Okay. At least we know.
Yeah.
That it's acting up.
Yes.
Change O2.
Yeah.
And
but this is
the problem. I'll have you come back.
Yep. Yeah, that works. And this is 100% not a vacuum leak. I can tell you that. It's not a fuel pressure issue.
About, right?
Yeah, it's not any of that. This is not something that's going to leave him stranded either. So those are all important pieces of info.
Yeah, it's his granddaughter, so you're worried about her.
All right, so I'm gonna clear this then, and then you decide how you want to handle.
Like I said, I'll let him, drive it a little longer. And
I like that.
Come back on.
I like that better. I like that better than throwing a part at it.
Yeah.
All signs point to contamination of that sensor. Yeah. So we'll go with that. I'm anxious to hear what your thoughts are underneath on how you guys would handle a problem like this. Thank you guys so much for joining us. We'll see you next time.